Okay, so when we first started looking at the trig functions without making graphs, the points on the unit circle, we just used this little um, formulation in terms of the x and y coordinates. We could also reformulate that in terms of the functions themselves, because remember on the unit circle, the y is the sine, the x is the cosine. So we could write these ratios and their reciprocals in terms of the other trig functions. Okay, and so we're going to start graphing tangent, cotangent, secant, and cosecant right now. Now the tangent you could think of as the slope. So first you start on the horizontal where the slope is 0, and then as the red point goes up, the slope starts increasing. When you're at 45 degrees, the slope is 1, and then after 45 degrees, the slope starts getting bigger than 1, and as the radial arms becomes closer and closer to a vertical, the tangent, the slope is getting bigger and bigger and bigger, and then once it becomes vertical, the slope's undefined. Okay, so again, thinking of the tangent as the slope makes that a little easier to get. So if we're looking at the tangent based upon the angle, right, then we start at 0, and as we rotate, as the angle goes from 0 to 90 degrees, at 45 degrees, it's 1. And then after 45 degrees, as it gets closer to 90, it becomes more and more vertical. We're going to infinity. Okay, and then once we go into the second quadrant, the tangents are negative. And so the vertical shifts just to the left. So at 91 degrees, now we got a very big negative. And then rotating down where you get to 45, then the slope is -1, and then down to 0. And then in the third quadrant, the tangents are positive. So just like the first quadrant, same kind of thing. At the 45 degrees, we go from 0 slope to 1. And then as we approach the next 90-degree location, the slope is getting more and more and more and more vertical. And so we're going to infinity, which is the equivalent of undefined, because infinity is also undefined. There's no numerical value that represents infinity. That's why we use a symbol. And then just like the second quadrant, once we rotate into the fourth quadrant, the slopes are negative. And so as we shift just to the left, so at like 271 degrees, we got a negative slope, is very vertical. And then once we get to the 45, then we have -1, and we go back to 0. So that's a unit circle map of what happens with the tangent function. And I found an app that did a decent job of making that a little more visual, right? So let me just reload this, and you'll be able, hopefully, to benefit from, yeah. Okay, so notice as we're going around, notice the graph shoots, oh, and now the slope is negative, so we're coming from the bottom. And then as soon as we get to the 180, oh, back to 0, and now going to the next vertical, shooting straight up, oh, and then jump. Now we're in the fourth quadrant, coming from the negative infinity, and then boom. Right, so notice there's 2 vertical asymptotes. And the vertical asymptotes are the 2 places where we got undefined values. On the unit circle, when we divide by 0, we're going to get an undefined value. Right, so when we divide by 0, that occurs here and here. Another way to think about infinity. Okay, so when we make this graph, you got your 4 quarters. All right, infinity occurs when we divide by 0. We get right here and right here. All right, so starting at 0, going to positive infinity. Second quarter, now we're in negative. So coming from the bottom, going to 0. Oh, sorry, this is the second quarter. So right here. And then the third quarter, which is the third section of this graph, going from 0 to infinity. And then the fourth quarter, starting from infinity. Now we got a negative slope in the fourth quarter, so we're starting from negative infinity and then going to 0. And that's what this graph does. And notice you don't really need the 45-degree locations to get the graph. But if you wanted to think of the 45-degree locations, that's where we get 1 and -1. So right here, that would be 1. And right here, that would be -1. All right, so if we multiply the tangent, that just makes this point go up a little bit. So if we multiplied this by 3, this would stretch up to 3, and this would stretch down to -3. Otherwise, the shape basically looks the same. Okay, and then we got the cotangent. Now, the cotangent is basically the tangent in reverse because it's the reciprocal. So instead of starting at 0, we start at infinity, at undefined. Okay, because again, the cotangent, if you think of it as points on the unit circle, we're dividing by y now. All right, and then we're going to go up here, 0, because then we get x is divided by y. And then over here, same thing. Now over here, yeah, I'm just going to put infinity. And then here, 0. All right, so once again, from infinity to 0, we're going to be in the positive region. And then we go 0 to technically negative infinity. We're going to be in the negative region where the cotangents are negative. And then when we get in the third quadrant, we're going to go from infinity to 0, and then it's going to be positive in the positive region. And then the fourth quadrant, we're going to go to 0 to infinity, and it's going to be negative in the negative region. So when we make this graph, okay, well, wherever we divide by 0, this is undefined. Cotangent is x over y, so it's going to be undefined first quarter, second quarter, and then at the end, fourth quarter. Okay, so in the first quarter, it's positive. So when we come from infinity to 0, that means on the positive side, infinity to 0. Now, the second quarter is going to be negative. So now we're going to go from 0 to negative infinity. And then the graph just repeats. Notice, just like the first quadrant to the second quadrant, the third quadrant to the fourth quadrant. Now, there is a lot of symmetry with these graphs. So basically, once you get it started, that helps you do the rest of the graph. So you don't really sometimes need to know the whole unit circle. You just need to know how you start it. So you go from 0 to infinity with the tangent, and then you can just repeat the pattern. Whereas the cotangent, you go from positive infinity to 0, and then you just repeat the pattern. So you can do that. Okay. And again, the same thing, we don't really need the 45-degree locations to make this graph, but if you wanted to think of the 45-degree locations, that's where we have 1 or -1. So this would be 1, and then over here, that would be -1. So if the cotangent here was multiplied by 5, that would stretch this up to 5, and that would stretch that down to -5. So that's basically what the amplitude does to the tangent cotangent graph. Now notice another thing here. There's 2 that repeat. That means the period is actually half of 2 pi. And that's true for this. Now this one got shifted and flipped over, so it's not quite the same as the cotangent. But if we went back another quarter to negative pi over 2, this graph would be here. So the tangent and cotangent have a unique period. They repeat every 180 degrees. And you can see that here. 180 degrees later, we start repeating. 180 degrees later, we start repeating. So the period is pi, unless you have a different angle expression. The width of a unit cycle contains 2 periods of the graph for tangent and cotangent. So the width of a unit cycle contains 2 periods of the graph of tangent and cotangent. So instead of 2 pi, the period is pi.